There we go. I've got that camera running. Well, I certainly am thankful that you joined me once again throughout our cruise across the solar system. As always, I am your host, Dr. Phineas Cortex. But let's not dilly-dally any longer. We've got another question of the day right behind me. Let's go see what it is. Let's see. This one is from a returning question asker. Her name is Zoe. And she says, "Dear Dr. Cortex, thank you very much for answering my question on what is the hottest planet that has been discovered so far. And thank you very much, Zoe. I enjoyed answering it for you. Now I come with a follow-up question. What is the coldest planet that has been discovered so far?" Well, quite frankly, Zoe, I'm one step ahead of you, as shortly after I finished researching the hottest planet, I got onto the coldest planet. And it turns out that the coldest planet that has been discovered is Oogle-2005-BLG/390LB. That is a mouthful, I'm afraid. But the average temperature on this planet is about -370 degrees Fahrenheit. It's located more than 20,000 light years away from Earth. And it's about the size of somewhere between Earth and Venus, I do believe. Do I have that correctly? Yes, I do have that correctly. And it's not really the atmosphere that gets it to be that cold. You see, its star that it orbits apparently has a low mass and a low temperature, that being a red dwarf star, the most common type of star found in the Milky Way. But anyhow, that's Oogle 2005 for you, and I hope that answers your question, dear Zoe. But as I have said in the last little broadcast of mine, we are nearing the end of our journey across the solar system. And we conclude that journey with none other than the planet Pluto. You know what to do, computer. Let's get some data, shall we? Now, Pluto, named after the Roman god of the underworld, was discovered in 1930 in a laboratory in Arizona by this person right here, Clyde Tombaugh. Tombaugh, am I pronouncing that correctly? I think I am. Anyhow, Pluto as a planet is very strange, as with the many other planets that we've talked about so far. You see, I've got this model of the sun right here, and now imagine this very large dashed line is the axis in where all of the other planets that we have discussed revolve around the sun. All the planets are like this, see? And this revolves around the sun in a very horizontal manner. But the strange thing about Pluto's revolution is that it is lopsided by 17 degrees. So as you can see, Pluto goes around the sun like so. And Pluto is a very odd planet when it comes to revolving around the sun. Sometimes it can be as far as 4.6 billion miles away from the sun. Sometimes when it comes very near to the sun, it is just 2.7 billion miles away from the sun. About the same distance as Neptune, actually. But anyhow, the diameter of Pluto is unfortunately very small. It's about 1,429 miles wide. It's actually smaller than our moon. and about 1/6 the size of our own planet Earth. The rotation of Pluto is about 6.4 Earth days. Not bad considering its size and sort of demographics. However, the revolution, look at this number, 248 Earth years. My gosh, that's like very long. It's unbelievable. But with all that aside, you know, considering the distances from the Sun to Pluto, it's logical, I should say. Now, despite being a rather small sort of heavenly body, the number of moons on Pluto is quite formidable for a rocky sort of planet. It has 5 in total, one of the major ones being Charon. I'm sure many of you have heard of the moon Charon. It was discovered in about 1978, 1979, if my mind's eye is correct. Now, as far as the composition goes on Pluto, being it that it is very far from the Sun and on the outer reaches of our solar system, we don't know not much about it, really. But from the data we've gathered, the crust of Pluto is made of this sort of frozen nitrogen, methane, and carbon monoxide. You see, because Pluto is so far away from the Sun, all of the gases that make up the atmosphere in Pluto are actually solid most of the time. So, when it gets to being solid, it seeps right into the crust as a solid material. And as you get farther into the innards of Pluto, you'll come across some liquid water ice and trace bits of ammonia. And as you get to the center, the core of Pluto, you'll come across, of course, some solid, dense ice and rock. And quite frankly, a very interesting fact, by the way, Pluto's core is estimated to be around 70% of Pluto's diameter. As a planet itself, Pluto is very dense. Of course, considering the pressure experienced by the vacuum of space, that in itself would be logical. Now, as far as the weather forecast, no atmosphere, so no weather, really. But since it is, of course, far away from the Sun, you can expect very cold temperatures at about -400 degrees Fahrenheit. Now, at this point, you might be wondering to yourself, but Dr. Cortex, we literally just went over on the question of the day that the coldest planet to have been discovered is that Oogle 2005, whatever, I already forgot the rest of the title. But that planet was at -370 degrees Fahrenheit. So what's going on here? Well, quite frankly, Pluto technically isn't a planet according to some experts. Throughout several years, since about the year 2005, the top researchers in astronomy have been having this big debate on whether Pluto is a planet or a category of smaller planets that they have dubbed a dwarf planet. Now, some really major points from each side of the argument are very convincing to differing amounts of people. And let's really go over that. So, let's go to the planet side for a second. People who support maybe the opinion that Pluto is in fact a planet. Well, first off, we have to take into account its discovery. It being discovered in 1930, you have to take into account that science wasn't as developed back then. And when they discovered Pluto up there in that laboratory in Arizona, the criteria for planets weren't as strict back then as it is now. So they dubbed Pluto a planet. Second reason, Pluto obviously orbits around the sun. Enough said? Enough said. Now, Pluto also has orbiting moons. Did I say that correctly? I did say that correctly. Now, obviously we know from planets like Mercury and Venus, who don't have any moons, that this really isn't a necessary criteria for planets. But this is proof that Pluto can sustain itself and sustain that spherical shape that sort of describes a planet that we all have in our minds. Therefore, just really rounding out the argument for Pluto being a planet. Now, for those that consider Pluto a dwarf planet, they believe that Pluto is too small to be its own planet. They also take into account that the fact that Pluto is a part of millions upon millions of other asteroids that are a part of this thing that we call the Kuiper Belt. Now, the Kuiper Belt being this sort of neighborhood of little asteroids and other heavenly bodies that dot the boundaries of our solar system. And because that Pluto is a part of this sort of clumping of all these other asteroids, really, Pluto in its size can be compared to those asteroids. I mean, Pluto, look at that. It's very tiny. That's nearly 1,500 miles of diameter. I mean, really, it can be compared to other asteroids, in their opinion. And they also argue that Pluto, in and itself, doesn't have enough of a magnitude. Now, that doesn't mean that Pluto doesn't have its sort of own gravitational force. Rather, Pluto is actually one of the only planets that we have discovered that doesn't have a magnetic field around itself. Now, with all of these in mind, and this whole big debate that's been going on throughout the field of science for all these many years, what do you think? Should Pluto be considered a planet once again? Or should Pluto remain a dwarf planet based on the information that we have received? Leave your opinion down below, right down below in the comments section, and let's see what everyone else is thinking. Well, all this talk about, Pluto being a planet or a dwarf planet, I must say that Pluto is still indeed a part of our vast solar system. And quite frankly, thinking about that vastness really makes anyone feel hungry. Well, I think it's about that time, eh? Jambot! Do you have another meal for this soul of mine?
I know just the dessert to celebrate with after our long journey. Using the schematics I collected from Pluto, I created an interesting treat called Pluto Dirt Bubba Balls. You'll need to grab 1 bubba box of bubba brownie mix, 1 cup of peanut bubba butter, 4 tablespoons of milk, and, oh, that's actually it. In a medium-sized bubba bowl, combine the bubba brownie mix and the peanut bubba butter. Stir and knead until combined. Then, add the milk until a decent consistency has been reached. Finally, taking tablespoon-sized scoops of the dough, roll the dough into bubba balls. That's all there is to it for this final planetary recipe. Bubba, back to you, Dr. Cortex.
Well, thank you very much, my friend. I think that treat will be a special commemoration for me and for you. And for you all as well. I mean, look at it. We have gone across the solar system in its vastness. It's been complete. Anyhow, I think that it is almost time for the next chapter on our special journeys across the stars. Let's go and see what the computer has for us, shall we? All right, computer. What have you got for me this time? And this little piece of paper again. I see. Very interesting. Well, I do believe that on the next segment, we will be discussing the sun. I think it's rather odd that we really haven't covered it so far. I mean, in fact, it's really the lifeblood of our own solar system. But I'm sure that we will get to that at another time. Once again, I'd like to thank my returning question asker, Zoe, for providing me with another question to answer. Once again, I do ask that you please send in any questions that you have right below in the comments section if you have any. Who knows, your question might be featured on the next question of the day segment. Well, I thank you once again for tuning in to me. Let's all blast off, as always, in 3, 2, 1!